We now find out, much to our amazement, that these single-cell organisms, when they're hit with radiation, their DNA is sometimes broken to shreds, and then, and here's the miracle, they repair the damage. They have mechanisms that allow them to repair broken DNA. If we can extract the genes that give us the blueprint for DNA repair, we can incorporate that in our body to repair damage coming from radiation, to make us resistant to forms of radiation that would normally kill the cell or induce cancer.
Cryogenics may also be a viable alternative to allow survival during the long journeys in space. The process of freezing human bodies, cryonics, was developed in the 1960s. Human bodies were frozen soon after death and stored in liquid nitrogen at 270 degrees below zero. When medicine has advanced to the stage where a cure is possible, they would be thawed. Freezing living people is far more difficult. When human tissue is frozen, ice crystals form inside the cells, which then expand and rupture the cell walls. The tissue loses its form when the body thaws. But some animals can naturally survive being frozen. The painted turtle produces a natural antifreeze, glucose, inside its cells. It prevents lethal ice crystals from forming and killing the cells. Scientists are trying to find out if the same technique could be used for freezing humans.
Our cells cannot withstand antifreeze made out of glucose. But since it's already been invented, since Mother Nature has already created antifreeze for fish and for frogs, why not simply modify our genes so that we too can withstand the rigors of suspended animation?
Rather than freezing the human body, it might be possible to hibernate.
I suspect that hibernating mammals are able to do what they do because of genetic components that we don't have, but we can probably pharmacologically mimic those effects.
Dr. Hartung thinks that the drug tetrodotoxin may be the answer. It's found in pufferfish and used in Haitian voodoo ceremonies to create zombies. It can be used to put animals that don't hibernate into suspended animation. In tests, the drug allows a rat to be cooled down until its heart stops beating. It can be kept in this state for 4 hours and then revived by slow warming. The drug keeps the rat's brain and tissue safe. Without it, the rat would die. In theory, tetrodotoxin or drugs like it could be used to help humans survive the rigors of long space journeys.
The resources needed to keep a mammal in hibernation would not be so great on a space flight because the primary requirement is being kept cold, and in space that's hardly a problem. Some members of a space crew be kept functioning so that they could maintain the near-frozen space travelers and make sure that everything is in place to bring them back to regular life.
The astronauts would be kept in suspended animation for years, perhaps decades. They would arrive young and healthy. But sending adults may not be the answer.
Why not simply freeze embryos? This is a technology that's already been done. Why not simply freeze embryos so that at some distant point we can hatch them in outer space, grow them to become humans, and then land on a distant Earth?
The ultimate solution to interstellar space travel may be to slow down aging. If the lifespan can be significantly increased, then traveling the huge distances to the stars in a single generation will be a reality.
Interstellar space travel will take a long time. We're talking perhaps centuries to thousands of years. Why not simply extend the human lifespan? At first that sounds outrageous. Who can control the human lifespan but God? However, in the last 5 years, there have been a number of astounding breakthroughs as we now unravel, gene for gene, the genetic basis of the aging process itself.
Aging doesn't occur because bodies wear out. It's due to genes.
We are, in some sense, programmed to die. Every cell of our body knows when it's time to die. Think of an alarm clock. Cells divide 50 times, and after 50 times, the alarm clock goes off and it says, time to die.
If there is a program for death, then by reprogramming the genetic code, we may be able to extend life. Dr. Rose has been studying aging in the fruit fly Drosophila. It's radically changed his views on growing old.
When I first got involved in aging research more than 20 years ago, like most people, I thought that aging was something you absolutely could not change. I thought that aging was an absolute. Now, I don't believe that at all, having doubled the lifespan of an experimental organism. I think aging is something that can readily be changed by changing genetics.
He's engineered a fly that lives twice as long.
These flies show that scientifically there's no fundamental barrier to postponing the aging of any organism. Scientifically, there's no reason why we cannot postpone human aging.
In a few thousand years from now, astronauts will be able to live for hundreds, even thousands of years.
I actually don't think that there's any fundamental limit to human lifespan. 2,000 years from now, we could be living 500 years.
In the future, the genetics of aging will be unraveled, and man will be in possession of an elixir of youth that will reset the human clock. But for interstellar journeys, living longer may not be the ultimate solution. What it is to be human may have to be redefined. The smaller the spaceship, the less fuel needed. Payloads will be limited. Bulky human bodies will be a waste of space. It's hypothesized that future space crews will be astronoids, astronauts who have bodies perfectly adapted for weightless spaceflight. These genetically created space travelers will spend their entire lives in the weightless environment of interstellar space. They will be small, light, and instead of legs will have an extra set of arms. This may seem like an extreme vision of the future, but scientists can already create new, sometimes questionable, versions of some creatures.
It has become so easy to manipulate the fly genome that you can turn genes around and turn them on and off in places that they don't normally get expressed. And so what scientists can do is the most outrageous things, like breed flies that have legs growing out of their head, or eyes all over their body. Because we understand how genes work, we can manipulate those genes very easily in flies and get the fly to develop in very bizarre ways.
There are special sets of genes that control the orientation of the shape of the fly's body. Scientists have now discovered similar genes in human cells.
In the 1980s, geneticists were shocked to discover that the same genes that control fly development also exist within the human genome and control human development.
One day, genetic engineers will be able to create new types of humans.